Thanks to Ezio, we've now got our timber parts, 77 through to part number 89. The point of assembly that we'll start at is our firewall or bulkhead. This serves a couple of purposes. Number one, later on this bottom face here is where the bonnet will shut down and close on. We've also got an offset, an angle difference to allow for the steering column. There's also cutouts in the bottom where it will clear the chassis rails. So there's no arbitrary location. It should all locate directly over the chassis rail. From there, we then put the floor, the rear bulkhead, the chassis rails and the cross beams. Just initially clamp all your pieces in place. When we're setting up the firewall, try and centralize everything. You may need to release the steering column just to get the alignment, and also the cutouts, try and make them even on both sides. That way you'll get the firewall in the center. With our screws, just initially start it off, and then with your power driver, slowly work it in. Don't do them all tight up first. Initially just loose and then go around and tighten them up again later. We've finished attaching our bulkhead to the chassis. The next thing we're going to do is our floor. Now, thinking about paint and refitting it together after it's all painted, we're going to take these holes out to 4.5 mil. That's to allow a little bit on assembly. When we set this board up, our floor, just allow maybe 0.5 mil or 1 mil clearance, etc., because paint, primer, etc., will tend to tighten up your tolerances a little bit. We're going to attach the floor to the chassis now, but we're also going to use these quick clamps just to set everything in position, lock it, then we'll just lift the chassis up and we'll screw from underneath. We've got 4 screws to do. We're up to installing our chassis rails now. We'll also use our kickboard to position the rails. We'll have to drill our holes out to 4.5 mil, and we've also got to make sure our mounting tabs are square to the timber. We've got our chassis rails and our mounting tabs square now. We're going to use the kickboard just to position the rails, so don't forget we need a little bit of material clearance for paint and primer. We'll also get this square to the chassis rails. The next thing we're going to do is clamp our chassis rails, mark the holes and pre-drill the holes to then be screwed and attached to the chassis. We're going to pre-drill both chassis rails. We'll be using a 2 mil drill bit. We'll drill down 20 millimeters. We'll be using 8 gauge by 25 mil long screws. That way it won't split the timber, so we can then attach it to our chassis rails. The 2 screws in the middle, you may have to get a long screwdriver to give you clearance, or remove the rear wheel so that you can use a power driver to drive the 2 center screws in. Don't forget we've got the last 2 screws that need to go into the back of the chassis rail. To line up our floor and kickboard with our chassis rails, work out the center line of the kickboard and the floor, install and then screw them together. We've got everything lined up now. 8G by 25 countersunk wood screws. We'll also pre-drill it with our 2.5 mil drill bit, straight in about 20 mil deep, and then we'll put our wood screws in. We've got our timber chassis rails in position, screwed. We've also got our kickboard. That's also secured and square to the floor. As a reference, we need to measure and just check 723 millimeters from the kickboard to the back of the chassis rail. This becomes critical at a later point, especially when we're mounting the guard. We need to set our position and length of our cross members now. We're ready to fit our first cross rail. Position this so it's square with the end of our kickboard. We can then F-clamp, hold it in position, and drop our batten screws into place, mark it, remove, pilot hole drill with a 4mm drill bit, 20 millimeters. Then we can permanently attach with our batten screws and also our 8G countersunk screws on the kickboard. We're ready to permanently attach our cross member, but just remember you've got to square this back up again so we go right back into the same place. We've kept the clamps on here so we have alignment to our kickboard and cross member. We've got 4 8-gauge by 25mm wood screws to join these together. On drawing 9, plan 3, we have our cross members spaced out. We need to measure 202 millimeters from the back face of our kickboard. That is to the outside face of our second cross member. These width measurements between each cross member are quite critical because later when we're positioning our guard, the bracket mount is already predetermined in its length. We're just checking the orientation of where the ends are for this cross member with a large square against the kickboard. We've clamped our second cross member. It's measured in position, square to the front cross member. We'll be repeating the same process as we did for our batten screws on our second cross member. I haven't tightened it just yet because we've got to check our measurements, make sure we're square, 202 millimeters from the kickboard. We're up to our third cross member, which is 413 millimeters back from the rear face of the kickboard. So we're going to measure, mark and clamp and repeat the same process as we've done for 1 and 2. On final tightening of any of these pieces, it's always best to actually do it by hand. You always get a little bit of movement in the timber, and check your dimensions, 211 millimeters, because as I said later on, that will be quite critical. The final piece, we measure in 22 millimeters from this back vertical face of the chassis rail. We'll do the same, measure, mark, clamp, pre-drill, 4mm holes, and then we'll attach our bolts and hand tighten. That's all our major timber work done as far as our chassis rails, cross member, kickboard, everything's secured. We've measured out, everything is in its true and correct position. The next thing for us is to go on to the dash. We're up to part number 91, the sheet metal dash, which is made out of 1mm mild steel. We'll have a template that we have to cut. We'll also have to mark out our template, cut our sheet metal, fold, pop rivet, use nutserts and attach the dash to the car. Drawing 11, we have template T15. We're going to need a blank piece, 450mm by 210 in 1mm thick mild steel. Once this is cut out, we can overlay it onto our blank piece. We can then mark all our drill relief holes, outlines, and also we'll have our fold sequences as well. We've got our template overlaid on our sheet metal here. We can now mark out, cut, do our drill holes, set everything up, including following our fold sequence. Here's one that we've had laser cut previously that's got our holes and our fold lines. That's ready to go. We're up to drilling our holes now. We need 2 at 3 millimeters. We've got 8 at 4 millimeters, and we've got 4 at 7 millimeters. We're up to cutting now. We're going to be using tin snips, left and right-handed tin snips. We'll also be using our throatless shears. We could also use a guillotine to do the outside perimeter. So the small areas we'll be doing with hand tools, and then the others we'll be doing with the throatless shears. Make sure your scribe line or texture mark is directly in the center of the top cutting blade. So position and slowly apply pressure. Then we can come along later after all this is cut, use our tin snips to cut the small corner sections out. We can also use this to cut through the larger pieces, and again, just trim with the tin snips to fine tune it. You can cut as straight or as crooked on one of these as the operator can do. So you can make a mess or you can do it neatly. And you can cut a nice curve. We've done the bulk of the cutouts with our throatless shears. Now we can use our tin snips. Don't forget right-handed tin snips coming in with the waste going off to the right. It's not whether you're left or right-handed, it's what side the waste goes away. Now we've cut it out with tin snips. The smaller edges do tend to curl over a little bit, they get stretched, whereas the larger edges doesn't really change at all. What we're going to have to do now is just flatten it out ever so slightly. Now we're up to folding our dash. There's multiple ways we can do it. We can do it manually, or we can do it with an offset vise in a brake press jaw. We can also use a manual pan brake or an electric pan brake. So let's get started with the first step and do it manually. We've got some thick steel plate here. This piece needs to fit within these dimensions. It's 215 millimeters long. We've used some 40 mil wide, 5 mil thick flat bar, as long as the base is thick enough to support the material. So what we're going to do is, following our fold sequence, 1, 2, 3, 4, 5, we will be folding downwards when we do this manually, because we want the face of the bench to be supporting our piece. Then when we do it on a pan brake, we'll actually fold it upwards, as long as you fold in the same direction all the time. If you go down, they all have to go down. Bending this manually, we're going to use some edge seaming pliers. These are the 90-degree heads. So you go in there, squeeze as close as you can to the bend point, then leverage down, or your straight ones in, again leverage down, and we'll probably use a block of timber just to finish it off to make sure we get that fold line nice and straight and neat. Just a quick tip, after you've done the first fold, we then would clamp our second fold, but the bench is going to get in the way. So we'll have to move this to the corner to allow the piece to overhang from the bench. Fold 3, we need to offset from the table to give us some clearance for this piece to swing underneath when we're folding it. We're up to our 5th and final fold now. This is our 215 mil long flat bar that we previously cut, because that is going to be our fold point. You can see here we've used the F clamps to actually hold our flat bar in place, because it needs to be clamped and folded in this direction. Also, our short leg has to fold inside our triangular piece. They will then be pop riveted later. To help with our offset, we'll use the flat bar as a dolly so that this slides on the inside. We'll use our offset vise now to clamp this and then fold it. Just a quick trick, on the face of that block of timber, you need to make sure it's as close to your flat bar as possible. I'm not hitting out here, I'm hitting right up against that flat bar. And we'll start to a little bit more by hand. You can see here where this piece is underlapping the outer flap. There you go, and you can see the pop rivet holes are lining up. Now we've finished folding our dash, what we have to do is tidy up some of these fold lines, get them a little bit squarer, just neatening things up. So, using a brick splitter, a dolly to back it up, what we'll be doing is getting in there and working at about a 45-degree angle just to sharpen that corner up to take some of that loose radius out of it. You can see this edge is a little bit sharper and squarer now. The other thing is with our dollies, a planishing hammer, round face, rectangular face, it doesn't matter. See how it closes that gap up? And then we just move along until we get these faces nice and square and lined up. Changing dollies, hand tools. Using our steel plate that we had on the tabletop before, we can use a square face here up against this sheet metal edge and really get it quite square. There we go. Run the engineer's file over that and that should be fine. When we use our pan brake, we won't need to do any of this finishing work. It'll come off the machine ready to go. Now we've finished manually making our dash using basic tooling and a vise, I'll show you how to do the same thing using a manual pan brake. We're now about to fold on our manual pan brake. Our fold sequence is on our template T15. We've also customized various parts or fingers of the pan brake to individual sections or lengths. So we can now start to fold as per our sequence. There we go. Okay. We'll just reset. Slightly more than 90. And that's as far as I can go. So we'll then release and slide it along, lock it in heavy. Done. There you go. Our 200mm wide blade fits in to our 215mm internal measurement. That will initiate it. Now don't forget, we need to add a little bit more angle to this face and this face so that they slide inside each other. Otherwise, these two will foul on each other. We're up to the final part of this bend. We need to use a narrower section of fingers, 3 50mm wide pieces, because the total inside width will not fit in this area up here that's 200mm wide. So we slide this in, lock it, and when these two faces meet each other and our pop rivet holes line up, we're done. These are our two dashes that we've made. This has been done with hand tools. This one we've done on our manual pan brake folder. You can see by the sharp lines, fit, accuracy, speed, That's the benefits. The next thing we need to do is fit it together with our pop rivets. This is a dual purpose riveter and also nutsert gun. So I'm going to put it in the vise, lock it in position, and then squeeze the two together, and that will be the pop riveting done. I'm up to inserting the 5mm steel nutserts, so I'm just going to clamp this to the bench and then use our nutsert gun. We're now up to fitting the dash. We'll be positioning it just underneath the windscreen opening. However, we're going to have to refer to the plans for our measurements and location. On plan 3, drawing 9, we've got our position, location for the dash. We need to work out our centre line directly over the steering column, which is half of the firewall width, 440, 220 is your centre line. We then come down 3.5mm from the bottom edge of the lower windscreen opening. The next thing we need to do is to make up a drilling template so that we get the exact hole locations. With our dash, the short side is the top. So with a piece of A4 paper, overlay it onto the corner, keep it all nice and square, trace around it, cut it out, then we'll flip it over and we'll mark our hole centres. I've just put the template on the back of the dash, and you can use masking tape or magnet, it doesn't really matter. I've also marked the top of the dash so that we understand and know where the orientation of the dash is in regards to our drilling. To mark the hole centres, all we need is simply a dirty finger right there. Then we use a pencil, drive it through, and we've got a nice equal hole centre. Do that to all 4, and then we can set it up on the pedal car and drill it. With our drilling template, I've marked the centre line, top and bottom. We also need to mark the centre line of our firewall, which is 220mm in from the edge. We'll mark the bottom as well, above the steering column. Get some masking tape, attach it, mark it, drill it, and we'll be countersinking from the front side to allow our screws to sit flush. The holes are marked. I'm going to centre punch it, and then we'll drill through with a 5.5mm drill. Fitting the dash, we've got 2 different length M5 countersunk bolts. M5 by 25mm long for the top where it goes through a single layer of timber. M5 by 35, the longer piece for the bottom where it goes through 2 layers of timber. You always have to allow a little bit of play or tolerance, so just fit hand bolts initially very loosely, then orientate your dash to get everything sitting correct and square. That way it'll tighten up nice and neat. That's the end of plan 3. We've fitted our wheels. We've also done our structural timber, rail, cross members, floor and firewall. We've also fitted our dash. We're now up to plan 4.